In this unit, we're going to study trigonometry. This lesson is about the sine ratio. All right, hi everybody. In this lesson here, we're going to take a look at the sine ratio. So we're going to introduce to you the first of three trig ratios that we want you to get comfortable with. Now, a ratio is simply a relationship between two things with the same units, typically expressed as a fraction. Okay? So now what we're going to do here is I'm not going to develop this idea so much as I want to just show you the relationship and hopefully you'll get a sense of how this works here. So remember, we're only looking at one ratio here, what we call the sine ratio. So we're going to look at a handful of triangles here. Okay, and I'm going to show you what we get here. Now take a quick look. So for this triangle right here, we want to make sure that you see the opposite and the hypotenuse. So the sine ratio, just so long as you get this, the sine ratio, whoops, sorry, you don't see this. The sine ratio combines the opposite and hypotenuse. Now, bear in mind that when I talk about opposite or adjacent, that is always with respect to a given angle. So there has to be an angle identified for this to even make sense. I cannot talk about opposite without implying an angle that's being referred to. So here, in this triangle right here, this is the angle that's important, the 56.4. The side opposite that is going to be 15, and then the hypotenuse is 18. In this case right here, here's my angle, 25.4. Opposite that is going to be the 3. And then the hypotenuse is 7. And in this triangle right here, 59 degrees is the angle given. It's a reference angle. Opposite that is the 6. The hypotenuse, again, is 7. So now what we're going to do here is I'm going to take and I'm going to find that ratio of opposite over the hypotenuse. And we're going to write both as a fraction and then use the calculator to get a decimal. So opposite over hypotenuse is going to be 15 divided by 18. 3 divided by 7. 6 divided by 7. And now I'm going to go to the calculator and get decimal versions of this. So 15 divided by 18 is 0.83 approximately. 3 divided by 7, approximately 0.43. And then 6 divided by 7 is the last one there. That's approximately 0.86. Now, over here, this last column is the sine of theta. This symbol right here is the Greek letter theta. When you see that kind of 0 or O with a line across it, that is typically the symbol that we use to refer to an angle. Okay? So when you see that symbol, you can tell, it's like, okay, that's got to be an angle that they're referring to here. So I've got this sine of theta, sine of the angle. Now, sine is right there on my calculator. That's what we're referring to. So we're wanting to use the calculator here. So I'm going to press that button, sine, and I'm going to put the angle in there, 56.4. My calculator opens up a set of parentheses. Now, some of your calculators won't open up a set of parentheses, but it's helpful to do that. So I'm going to put parentheses around that. That's sine of the angle. When I press enter, notice that I am getting, sorry, I wanted to put theta there, but the sine of 56.4 degrees is approximately 0.83. Now, it's not exactly the same as the ratio I get here. It's because when we're dealing with these trig ratios, there is a little bit of rounding that typically gets done here, but it's the same thing here. Down here, my next one, I'm going to figure out what the sine of 25.4 is. Now, you can probably guess that it's going to be 0.43, but let's take a look. Sine 25.4, 0.43 when I round it. Again, it's not exactly the same decimal if you go on from there, but yeah. Okay? And then finally here, I'm going to evaluate the sine of 59 degrees. And again, I am expecting that to be really, and look at that, yep, is going to be approximately 8.86. So yeah, here we go. So the next question is, so what do you notice about the last two columns? Well, they're the same. They should be the same here. So we have just discovered that when you take the opposite side of an angle and divide it by the hypotenuse of that triangle, that's going to be what we call the sine ratio of that angle. The sine of that angle, when you go to your calculator and figure out what that is, it's going to give you the ratio when you do that division. So you can either compare the sides yourself here, or let the calculator tell you what that ratio is. Okay? So I'm going to say that again. So either you can look at the triangle here and determine what the opposite side is divided by the hypotenuse is going to be, what that ratio is going to be, or you can let the calculator tell you what that ratio is going to be. Now, it's helpful to know what that ratio is, and we'll see some examples where we use it in just a little bit here, but it's really helpful to know what the ratio is. So it is really helpful that the calculator knows what the ratio should be for every angle. Okay? When I change the angle, I change the ratio of those sides here. And so, for example, look at this here. The hypotenuse was the same in both these triangles. All I did was change that angle. But it does change the ratio of the opposite side over the hypotenuse. So, the sine of an angle is going to be equal to the length of the opposite side divided by the length of the hypotenuse. And you're going to see how this is significant. Sine opposite over hypotenuse. So, okay? And you see that up here. So if you're going to find an unknown side lengths or angles using the sine ratio, sine of theta is opposite over the hypotenuse. So here we go. Here's how you might use this. First of all, label the triangle with respect to an angle. So your triangle probably has some labels in terms of vertices and sides and whatnot. But now what we're going to do is we're going to overlay on top of that an additional bit of labeling, hypotenuse opposite adjacent. Then we're going to use the sine ratio. The hypotenuse and the opposite will have either a number or a variable, okay? So you've got to know one of those. You've got to either know the hypotenuse or you have to know the opposite, and then the other one is an unknown. Or you could know both of them and look for the angle, quite honestly. You could do that too. But we'll take a look at that in a bit here. So you replace the letters in the formula with the measures that are given. Theta will always be the angle. We were talking about that. Opposite and hypotenuse will always be side lengths. And then to solve for the unknown variables, remember what the what undoes works here. We're going to multiply, divide, cross multiply, and use for solving unknown side lengths here. And then I'm going to show you this in just a second. You're going to use that inverse button there, that inverse trig function there, to find the angle when you don't know it. We haven't really talked about that, but we will in just a moment. Okay, so now let's do some questions here, and hopefully after doing some questions you'll get, again, a sense of the rhythm of how these trig questions work here. So find the unknowns in the following triangles here. Okay, so here's my 30 degrees, okay, and what that does is that tells me that this side over here is going to be the opposite, this side right here is going to be the adjacent, and here's the hypotenuse. Okay, now I don't know the opposite, but I do know the hypotenuse. So when I create that ratio of opposite over hypotenuse, okay, opposite over hypotenuse, that is going to be x over 10. Now, I don't have the complete ratio here. I don't know exactly what that's supposed to be, but I know that the calculator knows. Because if I tell the calculator that the angle is 30 degrees, the sine of 30 degrees is equal to that ratio. So I don't know what this is by looking at the triangle, but I know what it is by cheating and looking in the calculator here. So now what I'm going to do is enter the sine of 30 degrees in here, and the calculator tells me that it's 0.5. So x over 10 is equal to 0.5. And now this is like 0.5 over 1. Okay, so now I can cross multiply. 1 times x is going to equal 10 times 0.5. And 10 times 0.5 is just going to be 5. So the unknown side here is going to be 5 units, whatever that is. And so there we go. We've used trigonometry. We've used the calculator. and an angle to find a missing side of a triangle. Okay, let's take a look at this one. The 35 degrees is given to us. This is what helps us identify that down here, this is the opposite side. This is the adjacent. Now notice that I don't give you any information about the adjacent, but I also don't ask you for anything about the adjacent. We'll get to that in a bit. And because this is opposite the right angle, this is the hypotenuse. If I build that ratio of opposite over hypotenuse, that is going to be x over 17. I don't have enough to build that ratio, but the calculator, I know the angle right there, so the calculator can give it to me. As long as I know that angle, I'm good. So here, sine of 35 is equal to, now this is more like what you would expect to see, okay, with a ratio here, with a trig ratio. It's kind of a long, messy decimal. So this is going to be 0.573, and I'm going to round it to 4 decimal places. That's usually pretty standard here. But I'm going to leave the decimal on my calculator. So down here, I recognize that I could probably write this as x over 17 equals 0.5736 over 1. I can cross multiply and get 17 times 0.5736. Now, when I multiply that out, though, I'm simply going to use the full decimal that I got there. Whoops. So multiply by 17, and I get 9.75. Okay, which is probably more decimals than I needed. I probably could have gone to the nearest tenth and been good with that, but there you go. So again, using the trigonometry, using the trig ratio to find a missing side. Let's take a look at a couple more. This time right here, again, here's our reference angle, which tells me that this side over here, this is the opposite. In this case right here, though, it's the hypotenuse that's the unknown. So when I set this up here, opposite over hypotenuse, that is going to be 9 over x. I don't know what that is, but again, I've said it a few times here. I know that that is going to be the sine of the angle that I'm given. Okay, because I used this angle here to tell me what opposite was, I'm going to use that angle when I figure out what the sine is. Now, sine of 40 degrees. And I'm going to go to 4 decimal places, so 0.6428, 0.6428. This is like over 1. I would cross multiply, so 9 times 1 is 9, and this will be x times 0.6428. And for me to get x by itself, I got to divide both sides by 0.6428. Now, but I'm going to use the full decimal here. So I'm going to say 9 divided by the answer that I just came up with. And I get a nice 14.00. So there's my value for the hypotenuse. And the fact that that's larger than the leg here, that is reassuring, because I know that the hypotenuse should be the largest side there. Let's take a look at this one. And this is basically the same question to what we just did. Now, notice it's already got some labeling on it. So this is equal to A here, okay? This down here is B, there's little c here. That's great, that's wonderful, and I want you to understand that kind of labeling. But for right now, for the moment here, here's the angle that's given, which means this over here, this side is opposite, and this is the hypotenuse. So that ratio, the opposite over the hypotenuse, is going to be 5.12 over c. Now the variable they're using there is c, and that's fine. We can stick with that. I don't know what that ratio is, but I do know that that will be equal to the sine of 31 degrees. So I go to my calculator, sine of 31, and we get that 5.12 over c will equal 0.5150, rounded to the fourth decimal place. Think of that as over 1. So when I cross multiply, it'll be 5.12 is equal to c multiplied by 0.5150. And then for me to get c by itself, I divide both sides by, 0.5150. And so here we go. 5.12 divided by that answer that I just came up with. And I get 9.94 is my hypotenuse. And again, I find it reassuring that the hypotenuse is the largest side. Well, at least compared to those two right there, the hypotenuse is larger than the leg. That's good. Now let's take a look at a couple of slightly different problems here. So now notice we've got a theta right here. That's the angle. Now that defines this is the opposite side, and that defines, and then this is going to be the hypotenuse. So when I look at that ratio here, opposite over hypotenuse, well, I have those two numbers. What I don't know is the angle. Now this is an interesting situation to be in. We haven't seen this before, where I have the full ratio here. So the question is, before, I could plug in the angle and the calculator would tell me what the ratio is. Well, is there a way that the calculator can go backwards from the ratio back to the angle? And the answer is yes. And the nice thing is about it, it's basically the same button that you're using right here, but it's this feature above it. So what happens here is theta is equal to the inverse sine of 16 over 18. So to get that inverse sine, I press second sine. And then I get this sine with a little -1 in the exponent there, which is telling me that this operation is going to be the opposite of the sine ratio. And then I'll plug 16 divided by 18 inside there. And then to the nearest degree, and usually we round angles to the nearest degree. To the nearest degree, that's going to be 63 degrees. So it's approximately 63 degrees. So that's kind of neat here. So we can also use that sine ratio to figure out what a missing angle is. So let's do that here. Now here, this could get a little confusing. This is the angle that we're given. The 5 is going to be the hypotenuse because it's opposite the right angle. So that's easy to see. But I have to grab the side opposite the angle here, and that's going to be the 4. So this is going to be my opposite. So my opposite over the hypotenuse, that ratio right there is going to be 4 over 5, and that will be the sine of x. And so again here, it's the ratio I've got. What I don't have is that angle that was supposed to give me that ratio. So I use the inverse sine of 4 over 5 to get x, and then I just go to my calculator. Second sine, 4 divided by 5, and I get 53. Approximately 53 degrees. Like I said, we usually round angles to the nearest hole. Okay, so one more question. The angle made between a ramp and the ground measures 18 degrees. Okay, so here's the ramp and the ground here. 18 degrees. If the ramp is 7.6 meters long, how far from the ground is the top of the ramp? How high up does it go? There's my unknown. So here's a fairly interesting practical example of where you might see this. If you're building like a ramp, okay? So here's your angle. That's the reference angle. This side over here, this is your opposite. The one that's, again, opposite the right angle, this is going to be your hypotenuse. So it's important to get opposite and adjacent and those things clear in your head. So the opposite over the hypotenuse ratio that I've got here is going to be x over 7.6. But I can cheat because I have the angle. I can let the calculator tell me what that ratio is. And so the sine of 18 is 0.3090. So 0.3090 over 1. And I cross multiply, so x is 7.6 multiplied by 3090. And I get that x is approximately equal to, now they wanted this to nearest tenth, so 2.3, and then meters was the units in this problem. Okay? And so there you go. So hopefully that gives you a little bit of a sense of how trig works, specifically how the sine ratio works. for finding sides and for finding angles. But this is the general pattern that we're going to follow for the other trig ratios that you're going to see in the next couple lessons.